Today we'll be working on finding the derivative of an ln function and the derivative of an exponential or e function. Let's start with our exponential function, which in our case is equal to e to the power of cos x. This is a good example of an exponential function, as it would also help us to understand how deriving trigonometric functions work, because it contains this cos right here. To make the rule for deriving e functions easier to understand, I'm going to replace our cos with a u, so that we will be left with y is equal to e to the power of u of x. You can see why I've done this now, as the rule for deriving exponential functions states that when deriving the function, we simply rewrite our e to the power of u of x, our original function, and we then multiply it by u dash of x, so the derivative of our u of x part. In our case, this is the derivative of cos x. Now that we know the rule for deriving an exponential function, we can answer our question. First thing we do is rewrite our e to the power of u of x. I've rewritten our e to the power of cos x, the original function. Next, we have to multiply this by the derivative of our u of x, which means the derivative of cos x. Now the derivative of cos x is minus sin x. Therefore, our answer is e cos x multiplied by minus sin x. And that's how we derive an exponential function. This is our answer right here. Let's try our ln function now. Our function, or y as it's called, is equal to ln x to the power of minus 3 by e to the power of x squared. However, this can be rewritten as ln x to the power of minus 3 plus ln e to the power of x squared. We can do this using the rules of logs. So our function is now ln x to the power of minus 3 plus ln e to the power of x squared. We can simplify our function further using another rule of logs. The rule can be seen on screen now. Using this rule, we can rewrite ln of x to the power of minus 3 as minus 3 ln x. And we can rewrite ln of e to the power of x squared as x squared to the power of ln. But ln e is equal to 1, so we can simply cancel this out and be left with x squared. Our function is in two parts, so we simply have to derive both parts separately and then add them together to get our answer. So we have to find the derivative of minus 3 ln x and then add it to the derivative of x squared. So let's try and do this now. Because minus 3 is a constant, we don't have to derive it. We can simply move it to the front and multiply it by the derivative of ln x. As you can see, the derivative of ln x is equal to 1 over x. So to complete the first half of our function, we simply have to multiply minus 3 by 1 over x. Now we have to derive our x squared. When deriving x to the power of anything, we multiply the x by our original power value and take 1 from our power value. This is explained in a much easier way in the formula on screen. So, when deriving our x squared, we multiply by the power value, which is 2, and then minus 1 from our power value. So we are left with 2 by x to the power of 2 minus 1, or, in other words, 2x. So the derivative of our first half is equal to minus 3 by 1 over x, and the derivative of our second half is equal to 2x. The last thing we have to do is simplify this. Minus 3 multiplied by 1 over x is equal to minus 3 over x. So the derivative of our function is equal to minus 3 over x plus 2x. And that's it. We've finished deriving our ln function.